So we're going to still do PVs and GVs today, but we're going to work with multi-step problems. So an inner function, a function inside of another function, kind of like f of g of x or g of f of x. So we're going to review where our calculator searches. So inverse sine, inverse cosine, and inverse tangents of what ratios are in quadrant 1? Positives. And then it returns to you an angle between 0 and 90. Who's the oddball in 2? Excuse me, 2. Inverse cosine of negative ratios. And then it returns to you a positive value from 90 to 180. Quadrant 3. Nothing. Quadrant 4. Inverse sine and inverse tangent of negative ratios, and it returns to you a negative angle between 0 and negative 90. All right, so remember that your PVs are the answer the calculator would give. So it wants us to solve tangent of theta equals square root of 3 over 3. So theta is missing, it's the angle. What do we use to find angles? When we're missing an angle, we have to use what type of a trig word? Rhymes with Schminverse. Inverse. So inverse tangent of positive root 3 over 3. So you have a positive ratio. Our answer has to come from quadrant 1. So we're trying to figure out the angle that has a y over x that gives you root 3 over 3. When a tangent has 2 3's in it, who does it belong to? Pi over 6. So your PV is pi over 6. And then our tangents are the ones that can have the or GV. Oops, wrote it number 2. Let me write it down here. So we got pi over 6. What other quadrant has positive tangents? Quadrant 3. What's the pi over 6 in quadrant 3? 7 pi over 6. So we're at 6 pi over 6 is quadrantal, 7 pi over 6 is here. How far apart are those two answers? Pi apart. So we can say the PV is pi over 6 plus every pi, or pi over 6, 7 pi over 6 plus every 2 pi. Let me know if you have a question on one of these. Number 2, sine of theta equals square root of 2 over 2. Theta is the angle. We use a what to find an angle? Inverse, because it rhymes with Schminverse. So the inverse sine of a positive. So what angle has a y value of root 2 over 2? Pi over 4. So pi over 4 is our PV. What other quadrant has positive y's? 2, 3, or 4? Quadrant 2 has positive y's. Are those two answers pi apart? No, so you can't give one answer plus every pi. You have to state the second answer. So what's the pi over 4 from quadrant 2? 3 pi over 4. So GV, pi over 4, 3 pi over 4, plus every 2 pi. And the inverse sine of 0. So 0 is neither negative nor positive. It wants to know where your y value is 0. So you've got 1, 0 and negative 1, 0. But we have to think the PV is where the calculator searches. So the calculator searches for your signs in 1 and 4. So it can't return to you what angle? What angle is this? Pi. It can't give you pi. So your PV can't be pi. It has to be the one over here between 0 and 90 or 0 and negative 90. What would it be? 0 and 90 or 0 and negative 90? 0. Oh my goodness. So your PV is just 0 or 0 pi. And then how far apart are those two answers? They're pi apart. So you could say 0 plus every pi, or you could say 0, comma, pi plus every 2 pi. So once again, why can't this PV be pi? Why can't your principal value be pi? It's not where it searches. Calculator doesn't search for signs in 2 or 4, or 2 and 3, it's 1 and 4. All right, so new stuff mixed with old stuff. Keep in mind, if you see a trig word, normal trig word, followed by an angle, your answer is a what? Normal trig word followed by an angle, it's equal to a ratio. If you've forgotten that, write that down. If you see an inverse trig word, what is it followed by? A ratio, and it's equal to an angle. Because we are doing compositions of functions today, we're essentially doing like f of g of x. We're taking a function and putting it inside of something else. Sometimes your final equation will be a trig word followed by an angle, and then your answer is a ratio. Sometimes it's an inverse trig word followed by a ratio, and then your answer is supposed to be an angle. So you have to be able to look at it and understand what it's giving you and what your answer is supposed to be. The other thing, make sure that you start inside out. So you do the inner function first, and then you work your way out. And you will always use principal values. So if you have the inverse trig word of a ratio, your answer is going to be an angle, and you use the PV value. So make sure you're working with PVs. So number 4, what is the outer function? What's the outermost function? Cosine. What's the innermost function? Inverse sine or arc sine. Inverse sine of root 2 over 2. So you always start with the inner function. So I'm going to highlight it so you guys can see. You're going to pretend that that outer function's not there. You're going to pretend that it's just the inverse sine of root 2 over 2. And if you see the inverse trig word followed by a ratio, it's equal to a what? An angle. And you're giving me the PV angle. So it's the inverse sine of a positive ratio. Your angle has to come from what quadrant? Quadrant 1. So what is the y? What angle has a y of root 2 over 2 in quadrant 1? Pi over 4. So that yellow inner portion gets completely replaced with pi over 4. So you'll now have the cosine of pi over 4. So like this yellow portion was equal to pi over 4. And now you have normal trig word followed by an angle. What is that equal to? A ratio. This is a function Friday. So now you want to know what is the x at pi over 4. What is the x at pi over 4? Root 2 over 2. Bada bing, bada boom. All right, number 5. The inverse sine of cosine of 3 pi over 2. What's the outer function? Inverse sine. What's the inner function? Cosine. We always start with the inner function. So we're going to do the cosine of 3 pi over 2 first. So is the inner function a normal trig word or an inverse trig word? Normal trig word followed by an? Careful. 3 pi over 2 is an angle. So normal trig word followed by an angle is equal to a what? A ratio. So we're plugging in, this is like a function Friday. You're asking yourself, what is the x at 3 pi over 2? So remember, 3 pi over 2 is down here. So you're over 0 down 1. So the cosine is 0. So that inner portion, the cosine of 3 pi over 2, gets replaced with what? 0. So we're going to have the inverse sine of 0. And so now you should say, hey, I've got an inverse trig word. Inverse trig words are followed by ratios. Your answers are angles, and you need the PV. So where does your calculator search for inverse sines? What quadrants? 1, and 4. And wants to know what angle has a y value of 0. What angle has a y value of 0 over here? 0. Why not 2 pi? Because 2 pi has a y value of 0. It's not between 0 and 90 and 0 and negative 90. So you have to give the PV. So the final answer is 0, or you could write it as 0 pi. So 0 or 0 pi. This is why it gets kind of confusing. It's like, am I supposed to give a ratio? Am I supposed to give an angle? So you have to really look at the trig word and what's followed by. Number 6, the cosecant of inverse tangent of root 3. What is the inner function? Because you always start with the inner. Inverse tangent of root 3. So you've got an inverse trig word followed by a ratio. That gets replaced with a what? It's equal to an angle. Yeah, an angle. So you have to figure out what angle has tangents with 1/3. The pi over 3's. So inverse tangent of root 3, it's a positive ratio, so our angle has to come from what quadrant? 1. So we're going to replace this inner one with pi over 3. But we still have the cosecant. So now you have what type of a trig word, normal or inverse? Normal trig word followed by an angle. Our answer has to be a ratio. Well, what is the ratio for cosecant? Cosecant is what over what? It's h over o. So we need to think about the ordered pair for pi over 3, which is 1/2 root 3 over 2. We have to do our ratio. What is our hypotenuse? 1 over root 3 over 2. Multiply by the reciprocal. We get 2 over root 3. And then what do we do with that? Rationalize it to get 2 root 3 over 3. So what is the cosecant of pi over 3? 2 root 3 over 3. So normal trig words followed by an angle get replaced with a ratio. Inverse trig words followed by a ratio get replaced with an angle. Number 7. Wait, does that say 5 or 6? That was 6, right? I just cut off my thing. Doesn't that look like 5, 7? Yeah, kind of. All right. Anyway, 7. The cosine of the inverse cosine of root 2 over 2. What do you... Some of you probably know what it is. What's the job of an inverse function? Like, what do inverse functions do? Like, what's the inverse function of, yeah, it's the opposite. What is the inverse function of addition? Subtraction. What's the inverse function of multiplication? Division. They undo each other, right? When I give you x squared, that's squared. The function is a square. How do you get rid of a square? You square root it because it undoes it, right? They're inverse functions. You have a cosine and an inverse cosine. What are they going to do to each other? They're going to cancel, essentially. They're going to undo each other. What should our answer be? Root 2 over 2. So if you don't recognize that, that's totally fine. You just go the long route. So you start with the inner function, the inverse cosine of root 2 over 2. So you've got an inverse trig word followed by a ratio. Has to get replaced with a what? An angle. So you're asking yourself, what angle has a cosine of root 2 over 2? Paying attention that the ratio is positive. So the angle has to come from quadrant 1. Well, who does that belong to? Pi over 4. So now we're going to have normal cosine of pi over 4. So normal trig word followed by an angle gets replaced with a what? A ratio. So now you're asking yourself, what is the x value at pi over 4. What is the x at pi over 4? Root 2 over 2. What? Crazy math. And all of these examples have been nice because all of the angles and all of the ratios have been located where? On the unit circle. But that's not always the case. Bum, bum, bum. The tangent of the inverse sine of 5/13. Are we on the unit circle? Is 5/13 on the unit circle? No. Oy. So you have the inverse sine of a positive ratio, right? This is the connection you need to make. The inverse sine of a positive ratio has to search in what quadrant? 1. So our mystery angle is located in what quadrant? 1. So this tells you that we are in Q1. So because it's sine and they give you the ratio, the 5/13 represents the opposite over the hypotenuse. So your OI is 5. Your her is 13. So if you have a 5 for the y and a hypotenuse of 13, it is a triple. It's 12. If you don't know all of your triples, you do 13 squared equals 5 squared plus x squared. 169 equals 25 plus x squared, 144 equals x squared. Root it, 2 answers. X's and Y's, the O's and the X's can be positive or negative. The hers always have to be positive. We're missing the X, and it's in quadrant 1, so we choose the positive value 12. So if you know your triples and you know what quadrant you're in, just go straight to it. If you don't know your triples, work out Pythag. So we know we've got 12 for our X. All right, what angle is it? Do we know what angle it is? You guys should be like, no, we don't know what angle it is. We don't know what angle it is, Miss B. So anytime you have, not that kind of but anytime you have the inverse trig word of a ratio, your answer is supposed to be an angle. You're supposed to replace that with an angle. We don't know what angle it is, so you pick a generic angle. Theta, alpha, beta, whatever Greek letter you want to choose. Let's choose theta. So this yellow inner portion is theta. So you're left with tangent of theta, which means our generic angle theta is here. And now you have normal trig word followed by an angle. Your answer is a what? Normal trig word followed by an angle is equal to a ratio. So we use the ratio for the tan man. What do you know about tangent? It's opposite over adjacent. So what is our opposite? 5. What is our adjacent? 12. That's our answer, 5/12. Okay, this is kind of nerdy, but how would I find the exact degree for that? I'm gonna wrap day 1 back into this. How would I use this to find out how big theta is? Oh, Miss B, I don't really know what you're asking me. How would I use this to figure out how big theta actually is? I use the inverse because theta is a what? Theta is an angle. So I could say theta equals inverse tangent of 5/12, right? So think about this. This ratio is positive. Where do inverse tangents of positive ratio search? Quadrant 1. So if you recall, you actually did this on the day one stuff. So let me make sure my mode's still in degree. Yep. So second tangent of 5/12, 22.6 degrees. Bing, bada, boom. Cool, Misky. Okay, just a refresher. Number 9. Tangent of the inverse side of 1/3. Unit circle, not unit circle. Which one? Not. 1/3 is not a ratio on the unit circle. So pay attention to the ratio. Is it positive or negative? And that's going to tell you what quadrant you're in. The inverse sine of a positive ratio gives us, we are in Q1 again. We're working with sine again, and sine's ratio is O over H. So we know the y value is 1. The hypotenuse is 3. And this one is not a trip, like 1, 2, 3 does not make a dribble. So we have to figure out what it is using Pythag. So we do 3 squared equals 1 squared plus x squared. 9, 1, subtract. Do a little simplifying when we root it. Square root of 8. Root what and root what? 4 and 2. Which one's the perfect square? 4. So we get x equals positive 2 root 2. And why positive and not negative? Because we're in quadrant 1 and the x's are positive in quadrant 1. So our x is 2 root 2. We don't know what angle we're working with, so we replace the inverse trig word of the ratio with a generic angle. So we're going to say tangent of theta. So you have normal trig word followed by an angle. Your answer is supposed to be a what? A ratio. What ratio do we choose? Tangents, which is opposite over adjacent. So we take our OI, 1 over 2 root 2. Ooh, darn, got to do a little rationalizing. Oh, dang. There we go. Multiply by root 2. So we get on top root 2 over, how do we get 4? Root 2 times root 2 is just 2. It's the square root of 4, which is just 2, or you could say it's root 2 squared, which cancels. And then you have a normal 2 and a normal 2, which is normal 4. How could you figure out what the angle is? How could you figure out your degree for theta? The inverse tangent of root 2 over 4. All right, number 10. The inverse sine of cosine of 5 pi over 4. What's our inner function? What am I going to highlight in yellow? Cosine of 5 pi over 4. Unit circle, not unit circle. Yes, unit circle. Why? It's a pi over 4. Yay, we're back on the unit circle, but not for long. All right, so pi over 4, it would be our reference angle. 5 pi over 4 places it in what quadrant? So we're down here just past 4 pi over 4 where the signs are negative and negative. So when you replace this, the normal trig word followed by an angle, you replace it with a ratio. It's in quadrant 3, so we have to put in negative what? Negative root 2 over 2 is my yellow highlight, but that's not our final answer. Ooh, this is fun. So look at this one. You got the inverse sine of negative root 2 over 2. You have the inverse sine of what type of a ratio? A negative ratio. So the PV is where the calculator searches. Negative ratio PV for sine is what quadrant? 4. So we have to go to quadrant 4, and you have to give me what type of an angle? Angle is negative. So this is everything that your brain should be thinking. This isn't stuff that you have to write down on your worksheet or whatever, but this is stuff your brain should be processing. Inverse sine of a negative ratio. I need to go into quadrant 4. And I need the angle in quadrant 4 that has a sine is y of root 2 over 2. What angle in quadrant 4? Negative, turnover, negative pi over 4. Why not 7 pi over 4? Because 7 pi over 4 is in quadrant 4. PV says it's got to be negative. It's got to be where the calculator searches and it returns to you a negative angle. What? Look at number 11. That's Craig. The tangent of the inverse cosine of root 2 over 2 plus the inverse sine of 0. Whew. All right. Inner functions. What is the outer function? Tangent. So we're looking at 2 inner functions. We're looking at that guy and that guy. So we're going to have the tangent of, I'm going to go ahead and put my highlights there so you know where we're going to look like. All right. So the yellow highlight is the inverse cosine of root 2 over 2. Inverse cosine, inverse trig word, followed by a ratio. Your answer is a what? An angle, okay? Your ratio is what? Positive or negative? Positive. So we need the PV from quadrant 1 because it's a positive ratio. So what angle in quadrant 1 has a cosine, an x of root 2 over 2? Pi over 4. So my yellow got replaced with pi over 4. Over here, inverse sine. We worked with this a couple times today. 3rd time so far, I think. Inverse sine of 0. What angle has a y value of 0 where your calculator would search? 0. Remember, you've got 1, 0, negative 1, 0, but your calculator searches here and here. So you have to give the 0 pi answer. But 0 pi is just the same as 0. Still working inner functions. Pi over 4 plus 0. Yeah, don't think too hard. Pi over 4 plus 0 is just pi over 4. And now you have normal trig word followed by an angle. Your answer is a ratio. So we need the y divided by the x at pi over 4. Well, what's the y? Root 2 over 2. What's the x? So root 2 over 2 divided by root 2 over 2 gives you 1. So those 2 functions had ratios on the unit circle. Number 12. Highlighters might help if you want. We're looking at the inner function. You've got 2 inner functions. The inverse tangent of 4/3 and the inverse sine of negative 3/5. All right, what do you know about 4/3? It's not on the unit circle. It's not on the unit circle, darn it. So we're going to have to replace an inverse trig word followed by a ratio with an angle. Do we know what angle it is? No, because we're not on the unit circle. So we're going to call it what? We'll call it theta. So we're going to replace yellow with theta. Now we got to figure out what quadrant theta is in. So the inverse tangent of a positive ratio places this one in what quadrant? 1, because the ratio is positive. So we know that angle is in Q1. Let's look over here and see if it's a theta minus a theta or if it's theta minus a different angle. This gives you the inverse sine of a negative ratio. Inverse signs of negative ratios are in what quadrant? Quadrant 4. Different angle or same angle? Different. How do you know? Yeah, one was located in what quadrant? 1. The other was located in 4. So you don't want to put theta minus theta. You have to pick another Greek letter. Beta. Sounds good. All right. So now we got to figure out what the ratios are. So we got to figure out the missing pieces of the puzzle. So inverse tangent of 4/3. You guys said was in quadrant 1. So we got a little axe, boy, and her. Tangent is what over what? Opposite over adjacent. So my oi is 4. My axe is 3. So my y was 4. My x is 3. This is one you guys should know. Pythag triple of 3, 4, 5. Is the 5 positive or negative? And how do you know? Has to be positive. Why? The hypotenuse. It's the radius of the circle. All right. Now to beta. So this was beta. Now we're going to look at beta. We said it was in quadrant 4. So the ratio for this guy, we had the inverse sine of negative 3/5. So we know the ratio for sine is what over what? So like tangent was opposite over adjacent, sine is opposite over hypotenuse. The hypotenuse always has to be what? Positive. So the hypotenuse has to be what? 5. That means the negative to the fraction actually belongs to the 3, which is the what? The y value, the oi. So we're going to have negative 3. So the y here is negative 3. The hypotenuse is 5. When the hypotenuse is 5 and the y is a 3 or a negative 3, what does the leg have to be? Has to be 4. Is it positive or negative? Positive. Why? Because x's are positive in quadrant 4. If you don't know your triple, 3, 4, 5, how do you figure it out? Pythag, actually work it out. All right. So now we've got cosine of theta minus beta. Cosine of theta minus beta. Cosine of theta minus Cosetta! She's back again. Cosetta's back. Tell a friend. Cosetta's back. Cosetta's back. Cosetta's back. So cosetta of theta sits by her sister, cosetta of theta. They're not meant to be, so our sign is plus Sinbad of theta, Sinbad of theta. What? Identities from last chapter? That is insane. I know. All right. So we need the cosine of theta. Normal trig word followed by an angle gets replaced with a what? A ratio. So we need the ratio for cosine using theta's numbers. Cosine is what over what? Adjacent over hypotenuse, a over h. So going up to theta's chart, we're going to use 3 over 5 times. Now what's the cosine of beta? Normal trig word followed by an angle. We replace it with a ratio, but we use beta's values. So 4 over 5 plus, now we have a trig word of sine. Normal trig word followed by an angle gets replaced with a ratio. The ratio for sine is opposite over hypotenuse, but make sure you use theta. So we're going to have 4/5 times Normal trigward sine followed by the angle beta gets replaced by the ratio opposite over hypotenuse, but make sure you use beta's values. -3 over 5. 3/5 times 4/5. 12 25ths plus -12 25ths. All that work to get the awesome answer, our hero, 0. Cool, cool. If those angles had been on the unit circle, we wouldn't have had to use an identity. So like number 11, this is technically a sum for tangent, but we didn't have to use the identity because we were located, our angles here were located on the unit circle. When they're not, you have to. All right, 13. Cosine of 2 times the inverse cosine of root 2 over 2. All right, you can't do the little cancellation thing on this one because it's not cosine of inverse cosine, it's cosine of 2 times inverse cosine. So you gotta be careful. But we're gonna start with the inner function. Maybe. Highlighter, there it is. Actually, I'll just highlight the this part. All right. So we're gonna have the cosine of 2 times yellow highlight. Are we on the unit circle? Are we not on the unit circle? We are on the unit circle. How do we know? You've got root 2 over 2. That's a value on the unit circle. So this is saying what angle has an x value of positive root 2 over 2. So our ratio is positive. That means the PV will come from quadrant 1. So what is the angle in quadrant 1 that has an x of root 2 over 2? Pi over 4. So 2 times pi over 4 simplifies to be pi over 2. The 2 and the 4 reduce. So now you've got normal trigward cosine followed by the angle pi over 2. Our answer should be a what? A ratio. So we need the x value at pi over 2. So remember that's straight up here. So you're at over 0 up 1. So your answer is 0. All right, so let's hypothetically say that you were a silly rascal, okay? And you were like, oh, I want to practice my identities. And you replaced the inverse cosine of root 2 over 2 with theta. So you looked at it as cosine of 2 theta. This is called a what identity? Double angle identity. How many identities did cosine have for its double angle? 3. It had cosine squared, it had 2 sine squared, and 2 cosine squared minus 1. Had the 3. One of them had the built-in common denominator. That was the cosine squared theta minus sine squared theta, right? All right, so let's say you looked at it as the identity versus being able to use, like, go straight to unit circles. But you're like, oh, I know that this is pi over 4. So like instead of condensing here, let's say you went here. What is the cosine at pi over 4? Root 2 over 2, except you have to do what with it according to the identity? Square it. Minus, what is the sine at pi over 4? So what happens here? They cancel and give you 2. But what happens here? Minus, what happens here? 2. What happens here? What's 2/4 minus 2/4? 0. So So when you're on the unit circle, you can just use your unit circle values or use the identities. But when you're not on the unit circle, what do you have to use? Identities. Have to. No other option. If you're not on the unit circle, you have to use your identities. Last one. Conveniently, not on the unit circle. Sine of 2 times the inverse cosine of negative 3/5. How do I know this one's not on the unit circle? The negative 3/5. Oh, this one's fun too, because we haven't done one of these yet today. It's the inverse cosine of what type of a ratio? Miss Barry, you're so weird. The inverse cosine of a negative. PVs tell us that our calculator is going to give us an angle in quadrant 2 because of that oddball negative ratio. So ax, oi, her. Cosine's ratio is what over what? Adjacent over hypotenuse. What do you guys know about the hypotenuse? It's always positive, so it has to be 5, which means the negative belongs to the 3, which is the ax. So negative 3 for the ax, 5 for the her. Leaves you with what for the other leg? 4. You don't know 3, 4, 5. Pythag it out. Inverse cosine of a ratio. Any inverse trig word gets replaced with an angle. We don't know what the angle is, so we generically replace it with theta. So we have sine of 2 theta. So the yellow just replaced with theta. Since it wasn't an angle on the unit circle, you can replace it with an angle on the unit circle and then reduce and then do a ratio. We actually have to use an identity. So sine of 2 theta. Remember, you guys are supposed to have it memorized. 2 sine cosine, bingo. So 2 times the sine of theta times the cosine of theta. So this 2 can be written as 2 over 1 times the sine of theta. You have a normal trig word followed by an angle theta. Your answer is a ratio. So we need the ratio for sine using theta's values. So we need the O over the H, which is 4/5 times normal trig word followed by an angle gets replaced with a ratio. So we need the ratio for cosine, which is A over H, and use theta's values. Negative 3 over 5. Multiply across, bottom, bottom, bottom. 2 times 4 is 8 times negative 3. Negative 24 25ths. Bada bing, bada boom. So be careful when your angles are not on the unit circle.